start off with our laboratory experiment, we view the video as a guide provided in our canvas. As an example for our calculations, we took a screenshot of the table from the video with the corresponding values of the colors of the band of a resistor. After listening and taking down notes, we proceeded and searched in Google the 5 pictures of resistors with 4 bands each. And after gathering the pictures, we then moved to place them in the Word document for easier dissemination and access for our whole group. And each resistor was labeled and their colors were recorded in the table. And so after filling up the table, we then proceeded to our calculations.
For the first resistor, with an orange for its first band which equates to 3, and violet for its second band which equates to 7, and the multiplier was colored red which equates to 100, with a tolerance band of gold which was 5%. We placed the first 2 digits together and multiplied it to the third band's value as the multiplier, namely 37 times 100, which was equal to 3,700 ohms, with a tolerance of 5%, which means the allowed variation is 5% of 3,700 ohms, which is 185. It can go as low as 3,515 ohms and as high as 3,885 ohms. The same procedures were followed for the next 4 resistors, but with different colored bands. Namely, for the second resistor, with the red for its first band, which equates to 2, and black for its second band, which equates to 0, and the multiplier was colored red, which equates to 100, with a tolerance band of gold, which was 5%. Again, we placed the first 2 digits together and multiplied it to the third band's value as the multiplier, namely 20 times 100, which was equal to 2,000 ohms, with a tolerance of 5%, which means the allowed variation is 5% of 2,000 ohms, which is 100. It can go as low as 1,900 ohms and as high as 2,100 ohms. The same process was applied for the third resistor with an orange for its first and second band, which equates to 3, and the multiplier was colored brown, which equates to 10, with a tolerance band of gold, which was 5%. We placed the first 2 digits together and multiplied it to the third band's value as the multiplier, namely 33 times 10, which was equal to 330 ohms, with a tolerance of 5%, which means the allowed variation is 5% of 330 ohms, which is 16.5. It can go as low as 313.5 ohms and as high as 346.5 ohms.
For the fourth resistor, with brown for its first band, which equates to 1, the second band, black, which equates to 0, and the multiplier was colored red, which equates to 100, with a tolerance band of gold, which was 5%. We placed the first 2 digits together and multiplied it to the third band's value as the multiplier, namely 10 times 100, which was equal to 1,000 ohms or 1k ohms, with a tolerance of 5%, which means the allowed variation is 5% of 1,000 ohms, which is 50. It can go as low as 950 ohms and as high as 1,050 ohms. Lastly, for the fifth resistor, with green for its first band, which equates to 5, brown as the second band, which equates to 1, and the multiplier was colored red, which equates to 100, with a tolerance band of gold, which was 5%. We placed the first 2 digits together and multiplied it to the third band's value as the multiplier, namely 51 times 100, which was equals to 5,100 ohms or 5.1k ohms, with a tolerance of 5%, which means the allowed variation is 5% of 5,100 ohms, which is 255. It can go as low as 4,845 ohms and as high as 5,355 ohms.
Resistor values are often indicated with color codes. As we have observed in our laboratory experiment, practically all leaded resistors with a power rating up to 1 watt are marked with color bands. The coding is defined in the international standard IEC 60062. This standard describes the marking codes for resistors and capacitors. It includes also numerical codes, as for example often used for SMD resistors. The color code is given by several bands. Together, they specify the resistance value, the tolerance, and sometimes the reliability or failure rate. The number of bands varies from 3 to 6. As a minimum, 2 bands indicate the resistance value and 1 band serve as a multiplier. The resistance values are standardized. These values are called preferred values. The fixed resistor can be defined as the resistance of a resistor that does not vary through the change in temperature or voltage. Resistors are the most commonly used components in electronic circuits and devices. The main purpose of a resistor is to maintain specified values of voltage and current in an electronic circuit.
A resistor works on the principles of Ohm's law, and the law states that the voltage across terminals of resistors is directly proportional to the current flowing through it, while resistance is termed as the hindrance of the flow of electric charge. Ohm's law states that the temperature as constant, the voltage between any 2 points in a conductor charges directly with a change in the current between 2 points. The resistance of a wire directly proportional to its length and inversely proportional to its sectional area. Resistor's color coding uses color bands to quickly identify a resistor's resistive value and its percentage of tolerance, with the physical size of resistor indicating its power rating. The 4-band color is the most common variation. These resistors have 2 bands for the resistant value, 1 multiplier and 1 tolerance band. Resistors are always read from their left to right. It never starts with a metallic band on the left. If the resistor has a gold or silver band on the one end, you have a 5% or 10% tolerance resistors. The chart below shows how to determine the resistance and the tolerance of resistors. The table can be also used to specify the color of the bands when the values are known.
Resistor color coding uses color bands to quickly identify a resistor resistive value and its percentage of tolerance, with the physical size of the resistor indicating its ohm rating. The color orange, violet, red, gold, black, brown, and green are used as tolerance codes on the 4-band resistor only. The 4-band color code resistor has 3 color bands on the left side and 1 color band on the right side. The 3 color bands on the left side were very close to each other, and the 4th color band on the right side is separated from the first 3 bands with some space. The 3 color bands on the left side are grouped together to indicate the resistor resistance value, and the 4th color band on the right side indicates the tolerance of the resistor. It has been observed from our experiment that each resistor with different color bands has different values in their resistances as well as their tolerance. However, Since all resistors were gathered have a similar color in their fourth resistor, which is gold, and the value of their colorants were all 5%. The first color bands have their corresponding digits which are placed next to each other, and the third color band was used as a multiplier with its corresponding value as well. As we observed from our data, the third band, being the multiplier, greatly affects the final value of the fifth resistor.
In conclusion from our experiment, the value of resistance of a fixed resistor using the color coding technique was determined. Using a 4-band resistor, the first two bands' corresponding values were placed together and multiplied to the third band's values as the multiplier. Lastly, the fourth band signifies its tolerance.